Are we live?
I am waiting for YouTube to do its magic. There we are.
Yeah, amazing. Hello, everyone. Hi, Celeste.
Hello, Elena. How are you doing?
I'm good. We have amazing weather. I'm sarcastic here in Berlin.
This is true. So, Elena and I are both in Berlin. Hello to everybody who is joining us on the stream. Uh, what are we doing today?
Oh, we are going to play with OpenSearch and Node.js today. Celeste, what actually programming language do you usually prefer?
I don't have a huge preference. So, I guess a bit of background for me is I started in all of this as a technical writer and I've done a lot of documentation. And as a result, I kind of picked up whatever language the company I was at was using. Um, I actually know the most about Java when I really think about it. That's what I know the best. And I think probably JavaScript is my second best.
Nice.
Uh,
So
it's
today,
probably the one I've written the most of personally.
that's cool. Uh, our viewers, please put what is your favorite language. And I would not judge you if it's not JavaScript. Um, I actually, in the past, I was a full stack developer and I worked a lot with JavaScript. So my heart goes there, but I'm also impressed by Java and other languages and Python. Oh my God, Python is amazing. I don't know much about, but together with ChatGPT, we usually write very nice Python code. Yeah, so today we are going to work with OpenSearch and we will be using Node.js. So a bit about OpenSearch. So let me actually share my slides. I don't have much, but I will share so that we can. Okay. Celeste, do you know if my screen is visible by any chance?
There you go.
Yes. Amazing. So today we are going to work with OpenSearch. And my another question to our viewers will be, who is actually familiar with OpenSearch already? Who worked or who did anything with OpenSearch? Just put in the comments if you have some experience, so that we will see what is our knowledge from people who watch us.
Personally, I had never encountered OpenSearch until I came to work for Aiven. Um, and I feel like I'm still not entirely sure what OpenSearch does.
So OpenSearch is everything we want from a search engine for data-intensive applications. And Celeste, but for sure, before hearing about OpenSearch, you probably knew about Elasticsearch, right?
I mean, I'd heard about Elasticsearch, but I guess my question would be like, what distinguishes Elasticsearch or OpenSearch more specifically from just like a normal plain text search?
Oh, OpenSearch and Elastic. So, like, just a bit of a history lesson here.
Yeah.
Uh, OpenSearch started as a fork from the latest open source version of Elasticsearch. That was like 2021. I don't
Mm-hmm.
remember. Like, this was like ages ago, like centuries ago already. During the past, is it 3 years, 2 years? OpenSearch just rocks. There were so many new features added there. So of course, it's a totally like those products are moving right now, different directions, maybe even. But with OpenSearch, not only you can search, do analytics, do observability, but also comparing to other alternatives. There is a lot of cool things which OpenSearch has. For example, modern observability plugin, or doing the security analytics, or working with Prometheus for metrics, or having powerful SQL language and piped process language for everything which we need. So there are plenty of other things apart from what we are looking today. Today we will have this first step to touch and feel how OpenSearch works, and then who whatever people want to do next and put that into the comments, we will cover that in the next sessions as well. So yes, but when it comes to the difference between just text search and OpenSearch, it's about the way how OpenSearch works with the documents, with those entities, and we'll see this in the examples, and how it indexes data, how it creates, like in the books, you have this the reverse index at the back where you can kind of find the words. Apart from that, OpenSearch also has vector search. So there are a lot of things which makes it very, very powerful.
So there's a lot of different ways you can use it, is the impression I'm getting. It's not just like a one size fits all.
Yes.
Okay, cool.
Yes, so today we are going to use it for discovery of the data. So there are like different Celeste total rights. There is like, we can use it for logs. We can use it for metrics. Like aggregations is a huge part of it. We are going to take an example doing something delicious. I mean, depending on the opinion of people, but what we are going to do, we are going to look at the recipes. So we will use a Node.js project for which I have a GitHub repository. I will give, actually, Celeste will give you a link in a second. We still will come to that. But for now, we will use a Node.js project. And you will need for that Node.js, NPM, and Git installed. In case you don't have those, you can still catch up and install Node.js, NPM, and Git. Or you can alternatively use Gitpod, which will be also part of the GitHub repository or extra link we will provide you. Then apart from that, of course, all of that would be useless if we don't have the OpenSearch cluster itself. We will help you set up that. And finally, we need the data. And for the data today, we are going to look at this data set. And you don't need even to download it because I already put it into the GitHub repository. And this data set has 20K different recipes. And it has information about like nutrition, like how many different properties it has, how many different things, and like ratings and everything which we need. So we already have it as a part of the repository. So let's start with this, and we are going first install our OpenSearch cluster because then we can do, meanwhile, while it's being set up, other steps. So you will need the link which Celeste, if you haven't posted yet the link.
The sign up link?
Yes, sign up. That's
all right.
We'll do that incognito window so that I can kind of pretend to be a very independent person. So I will close this. And if you follow this link, you will get to this landing page. And over here, you can register for your own account with Aiven. And I will use continue with email, whatever choice you have. And here I will put my name. I will put my email address. I just registered that email address recently just for the workshop purposes. So it's amazing, Elena at gmail.com.
So while Elena does that, let me explain a little bit about what Aiven is. So Aiven is an open source data platform that lets you deploy technologies like OpenSearch or MySQL or Postgres or Kafka and more onto the cloud of your choice, including your own cloud account, if that is what you choose. And it also lets you integrate between all of those really, really easily and provides a whole bunch of robustness on the back end. So the amazing Elena is now waiting for her account to confirm, and we hope you're all following along with that lovely sign up link on the screen. And you can take it from here.
Yeah, so once you registered, you will get an email. And in that email, you will have activate your account link. So email will be something with please confirm your Aiven registration. So you will have that a link to activate. You will just click on it. I will just post it over here and I will press it so that email confirmed. And then I can press to get started and to provide some information about myself. So here, to complete the registration, you can enter again, like clarify your name, your company, organization name. I will put here that my first project will be, I don't know, I will put it Amazing Elena as well. And then done, and we are ready. Okay, I will put it. How about actually? Okay, I shouldn't be so not nice. I will put Amazing OpenSearch.
Just to be super clear, if you are following along by signing up to Aiven, you will get a free trial, so you're not going to pay anything up front while we're following along with this.
Yes, exactly. Exactly. So that link, which I suppose probably to show on the screenshots, not screenshots, but also here. So that link which Celeste provided you, it gives you some extra credits, which you can use with Aiven. And you noticed I didn't provide any information about the credit cards or anything else. So you can use it and experiment it for free. And it's enough credits to experiment with multiple services. But today, we are going to focus on OpenSearch, right? So that's why over here, when you are registered, you will be at the services page, and you have the list of a lot of amazing different database technologies. So select the OpenSearch over here, click on it, and this is where we are going to create a new OpenSearch service, where we are going to load the data and experiment, but yeah, so we need to create it first. You can select your favorite cloud provider if you have favorites. Then for the service region, I would recommend to select something which is close to you. Warsaw is not so far from me, so that will be of Frankfurt. I will select Frankfurt. And then you can select the service plan. Here, I would recommend to use a startup. Hobbies might be a bit too small, and you might get some errors of sending the data or something. So I would recommend to use a startup or anything upper than that. And then finally we can call it OpenSearch. And I will create the service and start trial. And here you can see that we are using the free trial. So it's all still a trial. And then we have some additional information which you can select. For example, the allowed inbound IP addresses. I'm going to skip all these steps because this is not super relevant for our workshop today. So
what does the allowed IP addresses do, though, just for the curious?
I believe it will limit who can access the service.
So it's for security purposes. Cool.
Yeah, exactly. And then the connection details, but this we will do together. So I will skip this as well, and I will finish the setup. Yeah, we can integrate some stuff with OpenSearch. There are so many possibilities, but we have only 1 hour. So I think we will focus a bit like on what we are going to do today. And then you will land on the connection information of our service when you're done. And we still see that our service is being rebuilding. So you can imagine that somewhere, for my case, somewhere in Frankfurt region, there is something being deployed on one of the machines in the data centers. So while this is happening, we can do some other steps. But also I wanted to ask, in the chat, could you put if you are following, or maybe I'm doing something too fast, then I can also slow down so that we are sure that everyone who is following the steps has enough time.
So the last thing I posted in the chat, which is that lovely go.aiven.io/help, and I'll put it up on the screen quickly. We'll kind of get you to where we are right now, but in case you missed anything, we have signed up for an Aiven account. We have confirmed and opened up our beautiful new Aiven account, and we have created an OpenSearch service. It takes a little bit of time to build, so now we're just waiting for the service to build.
Cool. And I see in the comments that we have someone sharing that they used Verve, sharing that quick visualizations on IoT data for customers' demos mostly. Yeah, that's a good, nice case. And TypeScript, Node.js, all the stuff people like. That's good. So now, while it's being deployed, how about we go and we check the code for that project? So we have this GitHub repository, and you have two options here. I'm going just to go and take the code from this to clone the repository. I will select here codes and HTTPS and copy the link. But alternatively, if you don't want to use Node.js on your machine, feel free to open this project in the Git pod. For those of you who love Git pod, of course, you can use it as well. But I'm going to put this in the terminal, and I will do the git clone, and I will put the link to that repository. By the way, my terminal might look a bit different. I tried to make it more simple with S extension. If you're curious about the extension, ask in the chat. We will share the information about that extension which I'm using. Okay, but in general, like we are cloning the repository. So if I will check what I have OpenSearch Basic Workshop here created. And what I'm going to do right now, I'm going to open it with an IDE. So, I mean, you can use whatever approach you want. If you want to use text files, or you want even like in terminal to see the content of the files, you can do that. I'm more like a visual person. So I'm going to open the new project with the WebStorm. So I can go over here. And I will open it, and I will put the trust project, and also what I'm going to do so that we have a bit more space and we can in parallel run the commands and we can see the content of the project. I will put it next to each other. So you should have your project, which we cloned right now. And whatever terminal you prefer, you can use a terminal from your IDE. It's totally fine. Or, like me, I put the separate one so that it's a bit more visible. But in the project, if you just go and explore it a bit, you will see that, of course, we start with Node.js project. We start with package.json. And in the package.json, we have information about what this project contains. We have a couple of dependencies here. We are going to use the OpenSearch dependency, the client for Node.js over here. I'm also going to use .env to hide the credentials so that we don't make a mistake of committing those credentials in the code accidentally in the GitHub repository. And I'm going to use this make runnable library, which makes it very easy to run the code from the terminal. I'll show you later how it will be going. But this is our package.json. Of course, let's install those dependencies. That's what we need to do first. So I will go to the OpenSearch workshop and I will do npm install. This is how we are installing all the dependencies which are indicated in the package.json file. So we installed the dependencies. Next up, let's actually go and iterate a bit what else we have. So I have here files to work with the OpenSearch cluster itself, to index the data, to search the data, to aggregate the data. So we will look at them one by one. But before we do that, we need to connect our client and our server. And for this, I mentioned that we are using .env, and .env means that we have this file, which I put an example file, .env.example. You can copy it and remove the example part so that you have a simple .env file in your OpenSearch Basic Workshop. And what we need to do here, we are going to copy the connection line to the service. So this service URI property will be what we have in our connection properties.
So just to clarify for folks who have maybe never seen a .env file before, they're a super handy little file that lets you store things like service URIs, tokens, etc. For projects that you're working on. So you can create one for each project you work on, and it keeps things nice and organized for you.
Exactly. It can be production, development, and also by the fact that in the git ignore, I am excluding .env. We will never put it into the repository. So we avoid that nasty situation of committing the credentials. But of course, like you need the service URI, and this is exactly what we just created. So if you go into the console page over here in the connection information, you will find a service URI. Just copy it to clipboard and copy paste it over here. And in this case, we have, and this will allow us, because now if we go to the config.json, let me explain how it will work. So in the config.json, and I will, how do I, okay, I will keep it like this. So what we have in the configuration JSON, here I am connecting to the client. So we using the OpenSearch library, and we are creating a new client, and we are providing the information about the connection string, which we just added in the .env file. Here we also provide the information about where the recipes are located and about the index name. And all of this will help us to connect to the cluster. But to see how we are going to do it, let's go to the index.js file. In the index.js file, we have a couple of handy functions which we are going to use now. So we would like to bring the data into the cluster. And before we do it, actually, let me tell you about one thing about OpenSearch. OpenSearch works with indices, like index. Is it like Celeste, is it like plural for indexes, or is it indices, or is it both?
The plural of index is indices, so INDICE, yes. In this case, we're saying put the data in, we're injecting.
Exactly. So indices, I never pronounced it correctly before in this case. So we are working the single index. It's a single unit of data. For example, we will be working with a lot of different recipes, right? So we will put all those recipes into a single index. So each of the recipe is considered to be a document, and index is kind of a group of those documents. You can consider it to be a table, for example, in a database. But with OpenSearch, we work with a very flexible structure of each of those objects, and we call it an index.
So you used an example of like a book earlier when we were trying to explain search, where the word index actually comes from. Apologies for everybody. I tend to do a lot of editing for this team. Where the word index actually comes from is that section at the back where they list out all the topics word by word, and they tell you where the number of it is. That's typically the index of the book. And that's kind of the term that we ended up borrowing when we started building search engines, because that was the fastest way to search books back in the day, was to use the index.
Exactly. So that's like where the term comes from, but we use index when it comes to the search systems. I think it's a bit, I think it's a term which is used a bit too much, because it can be a verb, it can be a noun, it's used in different contexts, but it's simple. We are going to bring the data into the OpenSearch cluster. And this kind of bringing the data is called to index the data. So I have a method. And also I wanted to show you a bit of magic how we are going to call all those methods using our additional plugin which we installed. So normally when you use a Node.js to call the methods, you will need to write a bit of code, but here we will just copy node index inject data, and this starts executing this method. And while it's being executed, let me just share with you a bit how we bring the data into OpenSearch. And there are actually main two ways which we can use. First one is to bring the records, or like whatever data you have, item by item. And sometimes you want to do it when you have, I don't know, like a flow of data, and you just get them one by one. You can put those into the system. For us, it's different because we do have a bunch of data. By the way, that data is connected. Let me just show. Let me go back to the project. The data is in the full format JSON file. Over here, if you will go in this recipe, in this repository, sorry, as this is all the recipes which we have. It's a huge amount of data. And we want to bring all of the data into the cluster. So we are using the bulk method. And the bulk method, here I'm using just JavaScript simple magic of using the flat map. But the idea is that when you do a bulk operation with OpenSearch, you can do all types of different actions. So we do indexing of each of the documents, of each of the recipes. But technically, you can kind of mix indexing, then maybe removing some of the documents or something else. So you can, that's why we put the line what we want to do, and then, so the action, and then we put to which document we want to apply that action. So, and for us, it's just to index every document, every recipe. And then we use a bulk endpoint to bring it all into the cluster. And if I will look at this, we ingested 20,000 items, and we didn't have any errors, and it took us around 20 seconds. So all of this is good. Could you put in the chat, our viewers, if you are fine, if everything is working? I see that we do have some comments. Let me check this. So okay. Rajat mentioned that he can't reach the URL. Which URL are we talking? Okay, that URL got split over 2 lines, Tibbs mentioned. Celeste, could you double check?
Yeah, I have been able to click through to all the URLs. I'm clicking through on the YouTube side of things, just to be clear. So I'm okay, and I don't specifically know which URL Rashad is referring to. Dan.
Yeah, that's interesting.
Did you do an npm install, Dan?
Yeah, that actually does seem that then if you can try alternatively, try to run this node index get indices and to see what kind of error it will return you, because you should be able to see the list of indices. This doesn't have to do anything with the full format recipes JSON. Instead, it will just reach the server and tell us what indices we have, indices we have in the cluster already, and it tell us if that. Okay, you said you did that. Could you try to run this and see if that works for you or not? Because you should be able to see, and also you can double check. And if you double check, do you see the full format recipes JSON in your repository? So because that is the file which is mentioned there. But meanwhile, where we did it? So we were in the index JSON. So we brought the data. Then okay. Let me double check. Oh, that's interesting. I have a feeling that maybe the URL you used then is actually wrong. Celeste, could you actually post again the, because I believe Oh, I see. It's my mistake. I'm very sorry. It's my mistake. I think I will bring you a different URL right now. So I think we need a different one. Then thank you. That's actually a good point. I made a slight mistake.
Should we be using the one on Aiven Labs, Elena?
Exactly.
Okay, I've got the URL. So big apologies, everybody. Just to give you a little behind the scenes peek of what happened here. Elena and I usually have a lovely little document that we use to have all the URLs that we share out to everyone in preparation for the workshop. And there was a wrong URL in the workshop. So the actual repository, I'm going to post this in the chat, everybody. And I'm going to pop this up on the screen. So super sorry, we had everybody clone the wrong repository. So maybe let's give people about 5 minutes to clone the repository, and then maybe let's start again from end.example, and we'll just rewind.
Yes, of course.
Cool.
Of course. So yes, please clone that repository. I'm very sorry. I think it was my mistake of confusing things. Yeah, so in the repository, please copy the .env. So let me just go to the project. And over here, you will have the .env.example. Okay, great. Thank you, Dan. And don't forget to create your own .env file and copy the URL to the service which you have. And that service URL you will get in the page of your service in the Aiven console. So over here, it was my link. It contains all the information we need to connect to the cluster. Cool. So once you will inject the data, you might have noticed that I didn't really have any structure of the data of what we brought. So it's kind of, we just bring the bulk of data, nothing else. And OpenSearch is actually very, very smart at figuring out all the properties all of our recipes or whatever data you bring there has. And this is quite powerful. To be honest, I work with different data solutions, and sometimes you need to kind of define the structure of the data. And I totally understand it's often important, but it's so way easier when you just can bring the data, whatever you have, into the cluster, and then the system figures out what needs to be done with the data. But we are curious what the properties which we got there. So for this, we can run the method and get the mapping of the structure of the data. We call it mapping in OpenSearch. So if I will do the get mapping method, if I run it, we can see that we have plenty of different properties here. We have calories, we have categories, we have directions, ingredients, and so on. This still doesn't give us a lot of information. And to show you more or less, to visualize what the data we got when we ingested it, let's go to the OpenSearch Dashboards. And OpenSearch Dashboards, we will come back to the coding and Node.js just in a second, but just so that you kind of have a visual description of what data we have. OpenSearch Dashboard helps us with that. So on the landing page for OpenSearch service, if you will go to OpenSearch Dashboards and you open the link to service URI over here, so I will open it in a different tab and I will copy the password. So you have the user here and I will put the password, the user and admin. So again, if you go to the OpenSearch Dashboards, open the dashboards page and enter the information about user and password. And I will log in over here. Then we will explore on our own, even though you can add some test data over there. I will keep the tenant private. We are not going to explore this area, so you can keep it private as well. And this is a place where we are doing a bit of data discovery. But before we do the data discovery, we need to create an index pattern. So we already figured out that index is a collection of documents. And index pattern makes an easy way to have a collection of indices.
Indices. Yeah.
I'm really bad with pronunciation of those indices.
You're
So,
pronouncing it beautifully. It is a little confusing.
so index pattern allows us to define a wildcard expression so that we match multiple indices. So it's good when we want to combine stuff. For example, in OpenSearch, it's quite common that we have index. We will split, for example, we have logs which we come in from different sources, and we will have logs for November only, and then we have a log index for December, and so on. But we want sometimes to look at all of the data together, and this is why we use index, because we can combine multiple indices together. But for us, we are going to use only just one index there, but you need to create that index pattern, and I'm going to create it over here. Celeste, I think that I copied in the document this appendix, so people who are lost how to find that place can,
Let me.
or I will put it in our chat and you can copy it for everyone. So in this place, we will define an index pattern, and I will select index over here, click on the next step. For the time, we are not going to do anything. So you don't want to use a time filter for our recipes because it's not a real time data and we don't want to have it used. So, and we will create an index pattern. And then we see all the properties which we have in our data set. So now with that, we can go and we can start discovering data. So on the left, in the dashboards, we have several options. And the most interesting for us will be here, discover for now. This is a place, and I can make it a bit bigger. This is a place where we can look at each of the recipes independently. We can see that we have 20,000 items, and we can have information about each of the recipes independently. So it's a very granular way. In case you want just to check the information, we can put, for example, here the like title, and let's put the, what can we do, description maybe.
And the available fields are coming from the JSON data itself, right?
Exactly. So all those fields, OpenSearch figured out that we have plenty of those fields. So, and here we can, for example, look for something, let's do pizza and pineapple. And we found 3 recipes with Hawaiian pizza here. So we can use this interface just to explore our data. We can also do some aggregations, or you can use like filters, all stuff here. But we can also do some aggregations. For example, we can.
So question, Elena, what's happening on the back end when you search pizza and pineapple? Is it doing like a precise search or is it doing something a little fuzzier?
It is using the match search, I believe. Wait a second. We can actually see this, how it is doing. So for this one, this is the page which we have, right? But on the top, you have this inspect button. So we can see what kind of request was sent by the dashboards to OpenSearch. So if I click on that inspect, then we can see that the request was like this. It's a bit of a mess because I think it's kind of doesn't really care of making the request elegant. But you can see that the query which is sent, it's like Boolean query, which said that it want to filter data by, again, Boolean filter, and do the multi-match for pizza and for pineapple. So this is how it did. We can do it a bit differently also, but you can always see how exactly OpenSearch did it and also the response it received. So this is how it was behind the scenes, but we will come back to that in a second. What I wanted to show is just a simple visualization. We have different categories here. So how about we will do the tag cloud. Tag cloud is something like, it has a bad reputation, I think, among the data analysts because it's very simple. But I think it's an amazing visualization to see something like overall general information. So in the tag cloud, we use buckets. And for buckets, let's select the terms and let's select the field categories. And if you put 25 items, then we will see the most popular 25 categories in all of our recipes. Bon appetit, which doesn't really help much, but we see that there is a lot of vegetarian dishes, there is like peanut-free and other things. You can, on top of it, search for some particular or like narrow it. So we can say that something like which contains only fish, and then you can see that they're like pescatarian, healthy, and so on. So this is one of the many different visualizations which you can do, but this is how kind of you can explore the data so that you kind of can have an understanding what exactly we have there in our recipes. But of course, we are here for Node.js, so I think we should come back to Node.js, right? So in the Node.js file, we already have seen the index and we indexed the data. And we got the mapping. So how about we go and start searching for something? So let's move to the search.js file. Let me clean this. And in search.js, let's start with a simple match query. So Celeste, you asked a good question, is like how exactly OpenSearch searched for that behind the scenes. And it was using the Boolean query, which is very powerful, but technically we could do it a bit differently. We can use a match query, and a match query is quite a popular full text query. It kind of answers the question how well the documents match a query. So it will create, calculate the relevance score for each of the documents and returns us the most relevant ones. So for example, let's search for something which I find to be very German. Let's search for soups with beer and garlic. And see, and we do have
Both Elena and I live in Berlin, Germany, and neither of us are German. But that is.
I believe that neither of us actually tried the onion and garlic beer. So have you tried
Yeah.
it?
If you're curious about the other full text queries available through OpenSearch, their documentation is fantastic. So.
Oh yes, it's true. It's true. So, but you can see that actually, like what I was searching for, soups with beer and garlic, and OpenSearch could check all the recipes we have and find the most relevant, which contains the biggest number of words. Also knowing that, for example, the words such as with or and, they're not really like more like filler words. And not super important for the context. So that's part of the OpenSearch magic when it's doing a search. Apart from match, we do have some other things. Let me show you. How about we combine several? For example, we can run the query string search, and I like the search because it's so it makes it very easy to write very complex search within one-liners, which is not really good for maintaining that line later, but it makes pretty impressive that here what we can do, we can say that we are looking for a recipe which either has dessert or garlic in the title, or sorry, dessert or cake in the title, doesn't have garlic, like there are some desserts with black garlic, we don't want to have that. And we have also optional, but optional ingredients such as mango, caramel, or cinnamon, which is fine if you don't have those, but if they are in the title of the recipe, then it will bring the calculated relevance score higher. So we combine a lot of different things within one line, and we could find all of those fitting recipes for that definition. So this is how the query string works. Obviously, if we use that in the code, that would be quite complex to digest and maintain. By the way, I wanted also to say a couple of words how exactly we send those queries. So the client provides us an endpoint for the search. And what we need to set there is the index name and also the body of the request. Here, for example, the body of the request, and for all the search queries, it starts with query at the top level. But then it depends on what exactly we are looking for. For example, we have query string for this particular one, or the previous one we have seen, it was match phrase. So for the match phrase, we needed to indicate the field where we are looking for that. Oh, sorry, I'm sorry, we didn't look at the match phrase. We were looking at the match. So like also again, so we have the query at the top, then we have match, then we have the field where we are looking, and then what exactly we are looking for. And for the query string, similar structure. So there will be always a bit of a difference within the inner layers of that request. But yeah, so they are pretty similar. Once you start using some of them, you will start to recognize a pattern. Then OpenSearch is not only about full text search, because full text search is really good, but it takes extra. So for some queries, for example, if you want to find all the recipes where sodium value is equal to 0. For this, we don't really even need to calculate the relevance score. So this is what we called a term query. And the term query, it's defined as a term. So again, we have the query object, but within that, we have a term instead of a match or match phrase or query string. So this is a term. And if we run it, then we will get the list of recipes, and this is by default limited to 10, but technically actually the response is way bigger. But we get all the recipes which have sodium value is equal to 0. We can also paginate this, do whatever magic we need, but the idea here is that in term requests it's way faster. So some requests you don't really need to have a you don't need to do extra work to calculating that relevance score or analyzing the data, because we just need to answer the question which documents match a query. So it's we just find the, for example, exact value for the sodium or a range of values. In that case, we can do it way faster. So it's a
question for you, Elena. Where are the terms defined from? Like, so sodium obviously comes from the recipes themselves, but like, are those being pulled in as an indice called sodium?
It's part of the document. So
Okay.
we have this index, and in the index we have a lot of documents, each for the individual recipe, and actually let me show you this. So if you go back to the dashboards and we go back to the discover page and we look at our Hawaiian pizza, we can see the information which we have for that pizza. We have the title, pan-fried Hawaiian pizza. We have also values for the sodium. We have the rating value. We have the protein. We have the ingredients list. So all of this is part of the recipe. And what is interesting with OpenSearch, the properties can be quite flexible. So comparing to, for example, when we have a Postgres database, where we know that we have these columns and then we can kind of enforce that you need to put the value to each of those columns for that row. OpenSearch is actually way more flexible when it comes to what data you submit there. So you can have some recipes which have all of those properties, others will have some other properties. So it's a very flexible world, which gives us, it's very nice to work for search purposes with documents. Of course, it has some limitations where sometimes you want to have a more stricter rules for the properties you have in Postgres. So it depends on the use case. But yeah, so here we have all those things, and interestingly, like we have the different types, and OpenSearch also discovers that we have, for example, date, we have the numbers, we have strings, we have floats, all of that.
Okay. So it's kind of just looking key value, key value.
Yeah, you can think about this like
Okay.
this.
Okay.
Yes. So this is about the search. How about I show you a bit of aggregation? So yeah, and with the search, you can run more of those commands and see how you can create those search requests for other things and experiment and break stuff. I mean, we learn best by breaking things, right? But we go to the aggregation file right now. So there is aggregate.js. And over here, what we can do, and I'll clean this, we can aggregate the recipes. And we have several aggregations in OpenSearch. First of all, we have a metric aggregation. This is used to calculate various metrics such as sum, minimum, maximum, average, all of that kind of mathematical stuff. And you have seen that actually, if you remember, that we have every or almost every recipe has a rating value. And the rating value, we can just see what is the average rating across all the recipes. And this is what I'm going to calculate right now. And the average is 3.71 something, something, something. So how we do it? We send, instead of query, we send the aggregations, or AGs for short, information, and we provide which metric we want to calculate. And examples are just statistics or the average, the maximum, and so on. And then we provide the field on which we want to calculate that metric. So here we calculated the average and on the field of rating. So I'm not sure it tells us a lot about the recipes, but for actually giving us a bit more information, how many recipes fall into the top rating or have the lowest rating, we can use what is called histogram. And histogram is just an interesting way to observe the distribution. So let me actually, it's easier to show rather than describe. So if I would run the aggregate and I will use a type of aggregation histogram, and histogram is a type of aggregation where we say we use the buckets. So the buckets we spread, we say that we have, for example, here we have 6 buckets for our recipes. And the buckets will depend on the rating which recipe got. If the rating is low, for example, like 0, I think it's from 0 till 1, then it will get those number of recipes there. Then we have higher, so each bucket will get a lot of, depending on the bucket, depending on the value of the rating, will get a different number of the recipes. So this is what this histogram is doing. We can do actually similar thing in the visualization. So if we will go to the dashboards and we will ask to visualize, let's save this and put it as a cloud and create a new dashboard. I would like to close that one, and I will create a visualization, and I will use the pie visualization. And here we will do the same. as we did right now in the code. But we will define buckets visually here. So we will do the split slices, and we will select the histogram from the list of the aggregations. And we'll select the field. Again, we will select rating. And I will not use auto interval. I will use like just one, so it will be a bit more visually appealing. And in this case, you can see that we got that numbers that we see that when it comes to like middle, for example, rating is 3. This is this chunk. We have a small chunk of the recipes which have high rating of 5, but we also have recipes without rating or 0. I assume this is actually those recipes which didn't have any rating at all. So in this way, you can do this either visually or you can do it through the code. I believe that, of course, for us, in many cases, we need to use the code for our applications. So you would probably will be using Node.js or another client to access OpenSearch. You can do the same for histogram with the dates or other properties. The last type of aggregation, which is very powerful in OpenSearch, is the pipeline aggregation. And pipeline aggregation allows us to combine multiple aggregation and create something more complex. For example, such thing as a moving average. And just to give you an example, I created this moving average function over here just to see how many recipes we added over the years and how this moving average worked with extra recipes coming into the data set. And if you run it, you will see that every year it starts pretty straightforward. So we had only one recipe back in this data set from 1996, and then the number is increasing all the time. But if you start and look at the numbers, how it added, you can calculate also moving average and see that this is, you can do even the math to do it on your own. But majority of the recipes actually appeared in 2004 of the recipes, yes. So this is different types of aggregations. So you can do search, you can do aggregations, you can do visualizations with OpenSearch. Play with these examples more. You can add more. This is totally not limiting. It's just like, I think, a lot of common functions which you can use with OpenSearch library, but there are more, so feel free to add more of functions and to explore the data set. Okay, so what do we have? Yes, and I believe that this is all which I wanted to share with you today. I have this feedback link so that you can leave us all the things which you liked or which you think we should improve about this workshop. And also I have some other links which you can explore more. We have a lot of articles in the Dev Center. I think, Celeste, you probably can tell more about Dev Center and all the magic we have there.
The Dev Center is Aiven's home for talking about the open source technologies that we implement on our platform. So we, of course, have the Aiven documentation, which is how to use the platform and how to use the API and how to use the CLI and all the amazing things you can do with Aiven. But the Developer Center, which I'll throw the URL on the screen shortly, give me just a second. Is where you can find articles on OpenSearch and MySQL and Apache Kafka and Apache Flink and a number of different technologies. And they don't necessarily have to run on Aiven if you want to, but obviously we love it if you do. So that's the Developer Center. Elena, do you want to talk about upcoming workshops?
Yes. What do we have the next workshop?
We do workshops every single Wednesday. So the next workshop is next Wednesday, November 29th.
Wait, yeah. Do you see what do we have there next time?
I am looking for that for
Is it
you right
Netlify?
now.
I think it will be about Netlify, right?
Yeah, no, it's actually Maddie Stratton is going to be teaching us about Apache Kafka. Nope, he isn't. It's about Netlify. You're correct. I was looking at the wrong date. So the next workshop is going to be on the 29th of November. Our very own Maddie Stratton is going to be teaching you how to do continuous delivery with Netlify, and Aiven is the back end. I think that's a super cool workshop because I think that a lot of Netlify tutorials and content that you'll find out there is really around the static site generator piece. And it's really quite difficult to actually build functioning applications as a result, because all you can really deploy using Netlify is the front end. So that tutorial will teach you how to attach a backend to a Netlify app, which means you have the easiest deploy on the planet, but you also have a application that can be stateful and data rich.
Totally. No, it will be a lot of fun. Cool. It was really great to see everyone today. Thank you for all your questions. Thank you, Dan, for noticing them typo which I had. And I'm hoping that we will see you next time during the next Wednesdays.
Yep, join us next Wednesday or join us the Wednesday after that. You can go to aiven.com/workshops, but I will copy and paste the link in the chat for you to check out when our next workshop is and to sign up for an email notification. You can also follow us on YouTube, and you will see those live notifications go out. The third and final place you can find that information is if you follow myself or Elena on social media. Attached are our Twitter handles. And of course, you can follow Aiven at Aiven_IO. Thank you all so much for your time.
Thank you.
Thank you.
Next
Bye
time.
now. Ooh.